Are we on? We're on. Okay. So, this was going to be a Flutter demo, but I think it's kind of a matrix demo. But let's look at the bug. Yeah, we're working on a bug. Um, this is a prime number decider application, and I only picked that like that because it's a bad algorithm, super slow, and it'll make this secondhand hiccup because if I do it at the wrong time, if I don't use the foundation compute capability, this will just be running at the same time as the second hand is trying to sweep around the clock. So let's see what happens here. Let's move up. Is 9,039 prime? Nope. Very good. The next number is prime. It's going to take a second to decide. So keep an eye on the second hand, and maybe you're keep another eye on this stuff down here so you can see it go away and then come back. So boom, second hand stops. Oh, it didn't go away. Okay, so we'll get to that. So we saw that. So now that's great and everything is good. And now here, let's talk matrix. Now here is the problem. Watch this. And what's going to happen is this is going to switch back to 9,039,039 because I was silly enough to use toggling this as a reset capability. And so it's going to reset it so I can get back to the start of a nice stretch of lots of prime numbers in here, 9,041, 49, 59. Okay, so when I toggle this, I'm going to reset that to 9,039 and watch what happens. Whoa. So first it had the right answer, now it has the wrong answer. Okay, so you attempted to, we all want to say race condition. What a great phrase. I don't know if this is technically a race condition, but let's look at what's going on. So uh, just to set the larger context, what we're talking about here is Flutter, for one thing, an amazing library. Thank you, Google. It generally is programmed by Dart. I don't like strong static typing, if you know me from my Common Lisp days. So we use ClojureDart thanks to Baptiste and Christophe and Nubank, who actually sponsored the thing. Money Talks. So this is ClojureDart, and we're also going to use Matrix, a very sophisticated and mature state management system. It goes back 25 years. It was used for a common Lisp pushing Cookstew over the wire web app, Tilton's Algebra. Check that out. It's not just front end stuff. What is this? Simulation. Oh, but I think it ended. Let's just. So this is a RoboCup Simulation League. I know it looks like a graphical application. It's just a replay of a game that's actually played over a UDP socket, but different clients talking to a game server. And when we put all those together, matrix, and we end up with Flutter MX, which is what we're talking about now, and that's been used by Benjamin Cherry to produce nice beach rentals, game stuff, play stuff, paddle stuff for a client. So it's live out there somewhere. Uh, today we're lately I've been looking at isolates, and I want to give a shout out to Plague Fox for that. Great stuff on isolates and all that. And I basically took all this and ported it to ClojureDart to get me rolling on isolates. So thank you, Plague Fox, for that. What's this? Oh, and this is the compute function that you saw. So let's get back to our problem here. Our problem is pretty simple. When I first looked at it, what's going on here? I mentioned that when you toggle the use ISO button, uh, it does two things. First of all, it toggles the button, so that'll propagate reactively through the application. But it also, this is my silly kludge, I'm assuming there's a widget out there named Primer, which is not a good idea. This is reusable. This is going to break pretty soon. I'm going to have to change this. But this was to me. I couldn't think of a better place to do this. This is where I'm going to reset it to 9,039. But make note of the sequence here. First, I changed the toggle on use compute. Then I reset the value. And of course, we're pretty close to understanding the bug right now, because the rule down here, the decision, well, over here, let's look at where the computation is done. This looks at two different things. What value am I computing? And do you want me to use compute? Well, it turns out that this is the first guy that comes through. If we go back over here, I should mention in matrices, this change to the toggle propagates completely before this next line executes. So if we go back over here, we see that, okay, this propagates completely, which means this thing changes while this guy is still 9,041,000. Okay, so we're going to kick off a computation of 9,041,000 again. Fine, no problem. We're going to use the compute function now. We get to use the Flutter compute guy, which will use an isolate, be very fast. That's great. Then what happens is, the second thing that happens is the change reset to 9,039,000 comes through here, hits this same rule. The formulas don't care who's, this is nice, declarative, clean stuff. The formulas don't care who kicked it off. When you're debugging, you can figure that out, but we're not going to talk about that. But the formulas don't care who kicked it off. They don't know who kicked it off. So they just get kicked off. So this is actually going to run twice. First when we change this, then when we change this. So the second one comes through. Why do we have a bug? Well, the second time it comes through, well, you can see in that, let's look in the log. Maybe I should restart that again and let you see the whole sequence here. Nope, we go again, we go yep, and now let's clear the log, okay, and bam, let's toggle, and what do we see? Computing in 9,041,000 in ISO 2, okay. This is the decision C's, slow as prime entry. So now we're actually doing the computation. This is and now we come through and prime computing 9,039,000 in ISO 2. What? Decision C's, oh, slow as prime entry 9,039,000. Decision C's 9,939,000 prime false, good. Decision C's 9,039,000 true. Uh-oh. So what happened was, where's the decision coming through? Right here. And it comes through and it says prime or not prime. And then down here, this guy comes down here and he's seeing that the value is 9,039,000 and he's saying prime, yep, but that was the decision off of 9,041,000. I hope I haven't lost you. So my first thought was, oh man, here's the problem. You're doing this goofy double kickoff here, and that's not really good matrix type of code. Then it occurred to me that actually that's not the problem. And the problem really simply is we are breaking apart the value being calculated and the decision about whether it's prime. So the only thing that comes back from the decision is true or false. True or false about what? Because I got values shooting around here now, async. What I need to do is keep them bundled together. So what we're going to do is we're going to change. We're starting to fix the program now. We're going to have this guy return a map, and it's going to be of, and the joke being function of, and then prime, bang, okay, and I'll finish up our map somewhere in here. This is a good place. Option command, and okay, so this is going to return now a map binding the value with the decision. Okay, so where do I use this? So this guy is going to come back and okay, so it's always going to be still. So I'm going to leave this. Oh, that'll be confusing, but we'll live. So where do we consume the prime? we come down here, we get here. So, no, okay. So what we really want is, now that we're returning a map, okay, we get to do some Clojure here. Keys. I guess the only one I need is prime, right? We're just deciding the color here. But I wouldn't want it to blow up. Well, it would always be true, so that it would always be green. I gotta stop talking and start thinking. All right, and then down here, likewise, we're gonna. And this is where we're gonna fix the thing. Well, we gotta do a couple of things here. So now I'm no longer looking around. And this should just be our debug. Whoops. Keys of. Okay. Key of prime. That's still good. Is of prime. Okay. Is this gonna work? All right. Okay, that worked. Okay. Booyah! Who is he? Okay, so that was the fix, which was to keep the value, keep the function of and the result together. And I didn't think it was going to go that quickly. This is tending to happen. Well, I guess that was the point. Let me shoot through that again, and let's just keep an eye on the second hand this time around. Okay, so this time, all right, so we're still not using Foundation Compute. Bam, you saw that hit. And we could we go up to 49. Bam, look at that second hand. Wow, okay. And now I can reset it. And, oh, okay, so it's still at 949 prime. Okay, so cool. Why didn't it change it back to 9,039,000? Well, it did, but oh, okay. So yeah, so it got kicked off when the toggle kicked off the decision while the current of was still 9,049,000, and that's it. That's the show. Now I guess just to the point was to talk about Foundation Compute, and there's nothing to talk about because it's just so simple. You give it the function, you give it the input parameter, it calls that function with that parameter and returns that result asynchronously. And and you get to use an isolate, this is very cool because isolates you're going to see in the next demo can be fairly tricky. So compute is a nice simple one, and they themselves recognize, don't use an isolate directly. Use compute that'll use an isolate on the platforms where that makes sense. All right. Whew. Okay. Bye.